Hello, so in this video we're doing another binomial expansion, but this time there's a couple extra little bits. So we're going to have to find what the expansion is equal to when we're given a certain value of x, and then we're also going to have to find the percentage error between that value that we get, the approximation, and the true value. So if we start off with part A, it says here, find the expansion of fx in ascending powers of x up to and including the x cubed term. So first of all, let's do that. Now we're given as our expression the square root of 1 plus 5x. And the important thing to notice that if we have the square root of 1 plus 5x, what we really have is just 1 plus 5x to the power of a half. So importantly, they didn't give us the power, but we just took what we were given and we rewrote it so that it just was to the power of something. You do the same thing with fractions. You do the same thing if something is being cubed or cube rooted or anything like that. So that's one thing to watch out for. And then from this, we can think about what our x value is, which in this case would be the 5x, and what our n is, which in this case would be 1/2. So now that we've got that done, we can then move on to actually expanding it. So our first term is going to be the 1. Then we have n times x, so the n is 1/2, and the x is 5x. Then we're going to have add 1/2, and then 1/2 take away 1 is minus 1/2, and that's going to be over 1 times 2, which is just 2. And it's, this time when we have x squared, it's the whole 5x that's being squared. And then we've got to do it up to the x cubed terms. We've got to do another one. So we're going to do 1/2 times minus 1/2 times minus 3/2. That's all going to be over 1 times 2 times 3, which is 6. And we multiply all of that by 5x cubed. So that's that. And then we can go ahead and simplify that. And I would just do this on a calculator if I were you. So we're going to have 1 plus 5/2x. And this one's going to be minus 25/8x squared. And this one's going to be plus 125/16x cubed. So we've now got our expansion, and that's part A all done. Next, we need to do part B, which says show that when x is 1/100, the exact value of your function is root 105/10. So for that, all we need to do is plug this value of x into here. So it says the exact value. So that's why we're plugging this x value into this function. We're not plugging it into our expansion here. If we plugged it into our expansion, it would only give us an approximation. So we can say that for b, we're going to take our function of 1 plus 5x, or root 1 plus 5x, there's a bit here, and we are going to let x equal 1/100, because that's what they asked us to do. So if we actually plug that in, we're going to get the square root of 1 plus 5 sets of 1/100, which is the same thing as the square root of 1 plus 5/100, which you could put that straight into your calculator and it would give you what they want, or you could kind of go through all the steps. And you could think of this, if you add these two together, what you actually have is 105/100, and then you can separate that into root 105, which is the top bit, over root 100, which is 10. So you don't really have to do all of these steps. You can sort of do those on the calculator, but that's how we do it. So now we've shown that when you plug 1/100 into this, you get root 105/10. That's all good. Next part then, it says find the percentage error that's made in using the series expansion in part A to estimate the value of f of 0.01. So this time, what we've just done is found the exact value of fx, when we plug in 1 over 100. Now we want to find the approximation. So for that, we're going to plug this 1 over 100 into this expansion here. So this time, we'd say that the kind of approximate f of 0.1, I mean, this is not standard convention, this is just what I put, is going to be equal to 1 plus, and then here we've got 5 over 2 of 0.01 plus 25 over 8 of 0.01 squared plus 125 over 16 of 0.01 cubed. So all I've done here is plug 0.01 into these x's, and then we pop all that in the calculator, and that should give us 1.024695,313. That's all the places that my calculator gives me, and you only want to write all of them. So we've got the approximate one, and we have the actual one up here. So now what we can do is find the percentage error by doing the difference between the two. So the difference between our actual and our approximate, and divide that by the actual. So we can do the root 105 over 10 minus, so that's the actual, minus the 1.024695313, which is our approximate, divided by the actual again, and then times that by 100. And we need the answer to two significant figures. So if we plug all that in, then we should end up with 0.00023%. So it's pretty accurate, it's pretty close. So our percentage error is really, really tiny. And that's because our approximate value and the actual value were very, very close. And that's it. So basically, we did a fairly normal expansion. Then we had to find the exact value of this. We had to plug 1 over 100 into our function. And then for C, we had to compare that actual value with an approximate value, which we found by plugging this x value into our expansion, and use those with the percentage error equation to find the percentage error. So I hope that all made sense. If you have any questions, let us know down in the FAQ. And otherwise, have a practice of some of these questions in the MCQ section. And I'll catch you next time.